is section 8.4 for pre-calculus, called relationships among the functions. And deals with what I usually call the trig identities. So we have the reciprocal identities that we're already familiar with, such as the cosecant of theta is 1 over sine theta, and the secant of theta is 1 over cosine theta. And then for tangent, I think we actually have quite a few, but cotangent theta is 1 over tangent theta. But also tangent theta is sine theta over cosine theta. So therefore cotangent theta is cosine theta over sine theta. And so basically we're going to use these identities to simplify expressions. Okay? And then we also have what are called the Pythagorean identities. And the Pythagorean identities are that sine squared theta plus cosine squared theta equals 1. And you can move those around. This also means that cosine squared theta is sine, no it's not, I lie, is 1 minus sine squared theta, and sine squared theta is 1 minus cosine squared theta. I mean, there's, goes on. And then we also have 1 plus tangent squared theta equals secant squared theta. And that too, you can solve that for tangent squared theta. You can, move that around. You can solve it for 1 equals secant squared theta minus tangent squared theta. And then the last one is 1 plus cotangent squared theta equals cosecant squared theta. And then, as I said, it's just a matter of using those identities to simplify expression. Like for example, we have 1 over sine x cosecant x. Well, any of those reciprocal identities, sine x times cosecant x is 1. Cosine x times secant x is 1. Tangent x times cotangent x is 1. Okay, so if we want to show some work, however, this is sine x times 1 over sine x, and that's over 1. So obviously, that's 1. How obvious it is, but here's another example. Secant x minus sine x tangent x. And when we're simplifying these, one of the rules of thumb is, to change everything to sine and cosine and see what happens. And so we do that here, and we get 1 over cosine x minus sine x over 1 times sine x over cosine x. Okay, and you can see now that we have 1 over cosine x minus sine squared x over cosine x. And we have common denominator here, so we can add those together. or subtracted in this case, and get 1 minus sine squared x over cosine x. And 1 minus sine squared x, looky here, right here, 1 minus sine squared x is cosine squared x. This is the same as cosine squared x over cosine x, which is 2 of those. This one would go away, this would go down to 1, and our answer is, that's simplified to cosine x. Here's another example. This is my third example. Sine theta, secant theta, cotangent theta. Theta got lost on that one. So again, if I change these all to sine and cosine, this one's already sine theta over 1. This is 1 over cosine theta. And this is cosine theta over sine theta. Looky there. Sines cancel, cosines cancel. The answer is 1. We have 1 plus tangent squared x minus 90 degrees. And this is one of the, it's a, what I call a co-function problem. The sine of 30 is equal to the cosine of 60. The I don't know, the tangent of 60 is equal to the cotangent of 90, or not 90, 30. So the way they say this, the cofunctions, sine x is the same as that parenthesis there, the same as the cosine of 90 minus x. And we can use that property. And cosine x is the same as the sine of 90 minus x. And tangent x is the same as the cotangent of 90 minus x. Okay. Those are also listed in your book. I just usually don't pay them a lot of attention because we don't use them a lot. It's important to know, that the sine of 30 and the sine of 60 are the same. The sine of 30 is 1/2, the sine of 60 is 1/2. You can verify that. I don't know how significant it is that I know that if I change this around and I bring out a negative, I need to bring out the negative because that needs to be 90 minus x, not x minus 90. Then I can take this right here and substitute cotangent squared x. So I get 1 minus cotangent squared x and 1 minus cotangent squared x I'm not sure. I've confused myself, sorry. Somehow when they do this problem, this goes back to plus. Oh, I think I copied it wrong. I think this was supposed to be minus. And so then this, sorry about that. So if I put this in big parentheses, then this becomes, it's one of the Pythagorean identities. This Pythagorean identity, 1 plus cotangent squared theta, is cosecant squared theta. So the answer here is cosecant squared theta, or in this case, we used x, I guess. Okay. We have cosecant x times the quantity cosine cubed x tangent x minus sine x. So again, before I do anything here, I want to change things to sine and cosine. So this is 1 over sine x times the quantity cosine cubed x over 1 times sine x over cosine x minus sine x over 1. And then at this point we could simplify or distribute or do them at the same time. And I'm going to do them at the same time. Excuse me. So I distribute to this first one. The sine x's cancel. The cosine here cancels with one of the cosines here. And what I'm left with is cosine squared x. And then I distribute it to the next one. The sines cancel, and I get 1. And that is almost the identity. The identity is that sine squared theta equals 1 minus cosine squared theta. And if you look, this and this are opposites. And so our answer is minus sine squared x, because those are opposites. And you know, your homework starts out so easy that it just seems so hard. You're to do 1 to 21 odd, and you need to show all your steps, not just put an answer. So my expectations, number 1 is cosine squared theta plus sine squared theta, and you're supposed to simplify that. Well, that's the Pythagorean identity verbatim. The answer is 1, and that's all there is to that. And that was part A. And part B has 1 minus cosine theta times the quantity 1 plus cosine theta. And that's, to me, that's screaming multiply. Multiply that out. So we multiply it out, we get 1 plus cosine theta minus cosine theta minus cosine squared theta, which is 1 minus cosine squared theta, which is sine squared theta. That would be the answer to that one. And then part C is sine theta minus 1 times sine theta plus 1. So my suggestion would be multiply that thing out. Okay. Look at number 3, part C, and it has 1 over sine squared A minus 1 over tangent squared A. What I would do is leave this as 1 over sine squared A minus 1 over sine squared A over cosine squared A. And then I would, fix that complex fraction by doing 1 over sine squared A minus cosine squared A over sine squared A. Now that I have a common denominator, you put those fractions together and simplify. And so I'll let you finish that as far as I'm going to go with it. So, just looking down the road, I don't know. This is number 5, letter C. It has cosine theta times the quantity secant theta minus cosine theta. And you could change that secant theta, you could change that to 1 over cosine, or like I said before, if you multiply something by its reciprocal function, you get 1. And it's just that easy. Minus cosine squared theta, and I think you can see where I'm going with that. Okay. I don't know. Look at number 19. Looks so difficult, but it's not. Cosine cubed y plus cosine y times sine squared y. So can't change everything to sine and cosine because it already is. But I can factor out a cosine y. And I get cosine squared y plus sine squared y. And by gosh and begolly, that's a Pythagorean identity. That's 1. So your answer is cosine y. Okay. So work on these the best of your ability. We will be doing the evens on Monday. We'll go over these and do the evens on Monday, and we will be, then I have a worksheet, and then we'll have the quiz over this.